So we added, right, for the last 2 lessons or so, we were adding areas, right? And now we'll be exposed to examples where you'll need to subtract, right? Subtract a section from another to find the resulting area. Okay, so example, find the area of the shaded region, right? So you almost have to think of it as there used to be a whole piece and then it got cut off, right? So we will call this shaded area, or actually the rectangle 1, and we'll call this 2. That triangle that's resulting here, which I'm going to use a red pen here so that you know that it wasn't there before. Okay. So in a sense, to get the total area, we will go 1, right, minus 2. Let's find the area of the first shape. Area of the rectangle would be length times width. Area of the triangle would be base times height divided by 2. You know that the base is 15, right? We copied it from this side, so the base is 15 and the height meets it at a 90 here, which is given to us here. So it's basically base times height divided by 2. And we get 675. And we get 75, right? So to get the total area here, we would go 675 minus 75, and that is 600 square meters. Would you be able to find the perimeter of this? It would be a bit more work because we don't know the slanted lengths here, so you'd have to use Pythagorean theorem, right? You take this triangle, cut it in half, then we have a right triangle here. Use Pythagoras to come up with that, and then we know both of them technically because they're the same. Okay, so I will do that on the side here. Perimeter, or underneath it, I guess. Perimeter. Right, what would that be? Find slanted sides. So essentially, you first have this. We know that this is 15, and we know that this is 10. Right? Then we're just gonna take the top one. We take just one of them. Like that. We know that there's a 90 here. We know that this is 10. This is 15 divided by 2, which is 7.5. And we're gonna call this x. All right. X happens to be the hypotenuse, right? So to find x, watch what I always do, right? We're going to take 10 squared and 7.5 squared, you add them in this case, and we're going to take the square root of the answer. That's just a faster way of doing it. It'd be 100 plus 7.5 squared There we go, 156.25. That's 12.5. And we are in meters. So for reference, right, you have found that one right there, and that one right there. Right, you have found both of those sections. Remember, okay. Did I do attendance, John? Not sure. Lucas and John. Okay. So let's finish what we started, right? So the perimeter would be, if you think about it, let's start up here. It doesn't matter, just right, 45, 15, 45, right? And then the two slants here. 45, 15, 45 plus 12.5 plus 12.5. Right, count like 1, 2, 3, 4, 5 sides. 1, 2, 3, 4, 5 sides. Doing some mental math here. 45 and 45 is 90 plus 15 is 105. All right, this gives us 105. 12 and a half and 12 and a half is 25. So that gives us 130. And that's just meters, okay? Who's not in group? This is supposed to be group 2, right? Who is not in group 2 that joined because you're here with a different class? Anybody? You're coming in Mondays anyways, but you happen to be group 2. Okay. Yeah. Got it. Okay. Let's try another one. And I'll leave some of the top parts. So if you're still writing that down, you got that time there. And go through this problem here. So I call the shaded one, like I'm considering the whole shape, right? The triangle. And I'm going to consider that little brick down here, number 2, right? So total area would be 1 minus 2, right? You have to recognize that you're taking away a chunk, right? And we're imagining this being there originally and then somebody cut it out, right? This would be a good, right? The letter A, right? I should have added another smaller triangle up here. We'll get creative down the road. Okay, so 1, the area of that triangle. What's the base? Well, we have to add a little bit, right? So 3 and 3 is 6, and 5 is 11. So it's 11 inches wide. So that'd be my base. So it's 11 times the height is 14, which is labeled outside that shape, and always divided by 2. That's just the area of a triangle, right? Area of that rectangle would be 5 times 2, right? Length times width. That'd be 10. And that'd be 100 and 54 divided by 2, which would give us 77. 77. There you go. And so now we conclude that the total area would be 77 minus 10, which is 67. And here it is, it's squared inches. And I'm not going to do the perimeter on this one. But if you did down the road, you'd have to find this slant, right? So you'd have to cut this triangle in half, right? Use the Pythagorean theorem to find this, and then you can add the distance around that shape, okay? So keep that in mind. Okay, we'll do one more. Just let you write it down if you need to. So your test is scheduled for November 30th, right? So we're going to test you on chapter 3, which is this stuff, and chapter 4, which is very much related. It's also measurement, but we do temperature and mass, stuff like that. We convert from Celsius to Fahrenheit, Fahrenheit to Celsius, even though these days we just ask Google anyways, right? What it is, but it's still important for you to know. So question 3. Still finding the area of the shaded portion. And I'd like you to give this a try, okay? Worst case scenario, and let's say you do make a mistake. We're not going to erase, we're going to scratch. But no, I want my notes to be perfect. If you scratch it, you will come back to it later and see, okay, I tried this, that doesn't work. It sticks more if you do it that way. you not get them all?
No, I got them all. It just wasn't calibration.
All right, let's see how you did. So the total area would be 1 minus 2. You know you need to subtract because that shape is going in and it's not shaded, right? Adding is normally when it's like extending outwardly, right? If you have like things stacked up and they're adding, this is subtracting, right? So 1 is the area of the rectangle, which is length times width. And the second one is the area of the semicircle, so you got to be careful. Right, it's semi. You can call it semi or like just half a circle like that. And you got to be careful here. So we know that it's going to be pi times the radius squared. So we're going to come up with the radius, square it, and then we're going to take that area and divide it by 2. Okay, because we only have half a circle coming into that shape. So what's my radius? My radius is going to be half of 102. Because 102 goes from end to end, and the radius is from the middle to one end. Right, so you got to look at the top and then say, oh, okay, that's the diameter. So half of that is going to be my radius. So that's 51 yards. Okay, so you plug this in here to get our radius, right? And then, so both of them are going to be larger numbers. It's 20,400. 4,085.6412. Oh, 64, sorry. And notice that if you got a bigger area for the semicircle than you got for the entire rectangle, then you know you did something wrong, right? So total area would be 20,400 minus 40. That's 16,314 0.36 and squared yards. 16,314.36 squared yards. I'll say it one more time. There it is. All right, and last one that I will do, still need to and then hopefully you'll have half an hour to do your own thing to work on this. Basically almost like a hockey rink. We're going to do area and perimeter of this. And I'm mixing it up, okay? So you should recognize that there's no subtracting at all here. In fact, you're going to have to add things together to get this area, right? So I'm going to use a marker or a pen, right? And I'm going to call this rectangle in the middle 1, right? You can call this 2 and 3 if you'd like, right? There's 2 half circles. And so the total area of this shape is a composite shape, right? 1 plus 2 plus 3. But notice that 2 and 3 is just a full circle. Right? The idea is that you have half here and half there. So you got kind of split in half and you put a rectangle in between. So we're just going to assume that this is basically a rectangle and a circle combined. All right? So 1, and the area there is going to be the rectangle, which is 423 multiplied by 154, okay? Because it's the length times the width. That should be fairly simple. 2 and 3, I'm going to do that at the same time to save us. The area there would be, area of a full circle would be pi times the radius squared. So we're going to find the radius and then square it. The radius would be 154 divided by 2, right? That'd be 76. No, 77, right? 77 feet. So you plug that 77 in there, square it. We don't need to divide by 2 because we're finding this half and that half. You could have divided by 2, and then you would have had to multiply it by 2 later on again because you're getting 2 half circles. So I'm just going to leave it at that. And let's see if I have enough room here. It's 18, 6, 26, 50, 28. And then the top gives you 65, 142. Total area. And I always use double the decimals along the way, just in case. And that's 83,768.50. And we are in feet, so it'd be square feet. Go ahead, John. Just don't wander the halls, okay? He has to go to the washroom. All right. Now what? Now we're going to do the perimeter. Just so you know, right? A lot can happen over the weekend, right? Distance around. So I can never say things enough. I'm a dad. I have 2 boys. You can tell them something and they look at you in the eye and they're like, yeah, got it. 2 days later, it's like, what were you talking about, right? So I repeat myself quite often. So those of you who remember things, you'll be annoyed by that, but trust me, I've seen it all. So the perimeter, we need to find, right, this curved part here and this curved part here. So how about we do this so that it really sticks, right? So this highlighted here and this highlighted part here, we're going to do this and this here, okay? Circumference. It's basically the circumference of a full circle. So that's 2 pi r. And that's 2 times pi times the radius, which you already determined was 77. And some teachers just keep the pi as is. They don't calculate it. And that's okay. Nothing wrong with that. Sometimes that's even easier. And then I'm going to do the 2 sections that run parallel, right? This side and this side. I'm going to do those 2 here. That'd be 423 plus 423. Right? So the perimeter would be essentially 452.3893 plus 423 plus 423, or 2 times 423. And watch your units. This is just distance around, so it's just feet. You're not filling up a space, right? You're finding out how long the fence would be around this rink, right? Not fence, but the boards. So square footage, it's how much ice would you need to cover, right? And this is your perimeter, which is how long would the board be around that shape. So you kind of have to think about it in pretty creative ways, okay? All right, so if you came through this, through my class last week, you should already have this handout that I'm about to show you. Maybe I'll just leave that there, and then you're still copying. It's called the Working with Composite Shapes. So if you didn't get it, if you're here in my class and wondering where is that, it's right there where the yellow formula sheet is sticking out, that stack of papers there. So you work on this. This is a mix between adding and subtracting for areas, as well as, pay attention, some have perimeter and some only have areas. So you got to watch out for that, okay? And the best part is, here's the best part, okay? After the first 2 pages, you have answer keys. You have the answers to those first 6 questions. And then you keep working, and then you will get the answers to those as well at the end, okay? So this kind of gets you back to everything we've done so far. And if you don't have it, I will post it for you at home, okay? So you have the PDF version of it. So it's actually, I'm posting it right now. I just clicked on post. So it should be visible right now. Just gonna do a little test here. Benedict, do you have this handout right here? Not picking on you, I'm just asking because you're in group 3. Maybe I'm also, yeah, okay, so group 3 has it. Gurjot, you're there. Tyrell, are you there too? I didn't mark you here earlier, but Gurjot and Tyrell or Isabella, do you have this handout that you're seeing on your screen right now? Gurjot, are you there? I should do this more often to see if you're sleeping. Luke, do you have this? Okay, Gurjot has it. Okay, so group 1 has it. Luke, do you have this worksheet? Okay, so basically, everybody, if you came to class, you should have that. And so just open it on the PDF online. Okay, so you have the rest of the class. Just stay online though and work on this. Check your answers. Show your work the way I've shown it to you, right?